Hello everyone, welcome to this video. We will talk about data transformations. So let's say we have some data for people and we'll have three features: net worth, age, and friends, where net worth can go from negative a million to positive 1 million. So maybe they're like $1 million in debt. Age is from 1 to 122 years old, and the number of friends goes from 0 to 10. But there is an issue with this data. Can you guess what it is? The issue is, in deep learning, bigger numbers could dominate smaller numbers, such as net worth, which goes from negative a million to positive 1 million, versus age and friends, which is just 0 to 122. So, how do we fix this issue where bigger numbers could dominate smaller numbers? We will scale things with either standardization or normalization. For standardization, update values to mean of 0 and standard deviation of 1. I will not go into the math of standardization, but just know that the range goes from negative 1 million to positive 1 million, and now it's negative 1.25 to positive 1.19. However, I find the math for normalization much easier to understand. Update values to range of 0 to 1. So now the smallest number becomes 0. The biggest number of 1 million becomes 1. And 79,000, which is almost in the center between negative a million and positive 1 million, should be close to 0.5. And here it's 0.5395. So the next question you might have is, when should I use standardization versus normalization? And the answer is, if you have an unknown distribution, use normalization. If you have a normal distribution, use standardization. So what is a normal distribution? It is where data near the mean are more frequent, such as height. Most people are of average height. And it is very rare to find someone that is either super tall or super short. And here I've given myself a reminder to show this file from earlier on in the course. So we ran this model earlier on in the course. As you can see, we scaled the pixel values with normalization from 0 to 255 to 0 to 1. Let's talk about feature selection next. Only use useful features. So maybe we have an example model that determines how likely a dog or a cat will get adopted from an animal shelter, and the age, height, and breed are probably really important for determining how likely that animal will get adopted. And we might notice that favorite food is either useless for determining that or close to useless. So we'll no longer use favorite food in the data. Or we could use feature extraction. So maybe we notice for the animals in our shelter that the older the animal is, the taller they are as well. So we'll create a new feature that combines these, and we'll call it maturity. So the next question you may be asking is, why should I care about feature selection and feature extraction? The reason is, there are downsides of too many features. One downside is overfitting. Too many features, the model can become too complex, higher risk of overfitting, and longer training. More features, longer training, it'll cost you more money. So just a quick review, we can either just not use useless features, or we can combine features together. Last thing I want to focus on is data transformations. For optimal model performance, use the same transformations for training data and new data, as you can see in this diagram here. And another reminder to show off that file we ran earlier on in the course. As you can see, for this normalization for pixel values, we ran it for our training data right here, and we did for our test data right here. Okay, that's it for this video. Thanks for watching.